All right, guys, so in this video, we're going to talk about integer exponents, specifically 0 and negative exponents. By this point, you really should know how to evaluate and simplify expressions with positive integer exponents, okay? So let's talk about 0 as an exponent first, okay? Any non-zero, and notice I've italicized that and underlined it, any non-zero number or expression that's raised to the power of 0 is equal to 1, okay? Which is fantastic. That makes it really easy, okay? 0 to the 0 power is not defined. So, again, we're talking about non-zero numbers. So, some quick examples. 5 to the 0 is equal to 1. Very simple, okay? Negative 12 in parentheses to the 0 is equal to 1, okay? Now, notice here, I've got negative 12, not parentheses, okay, to the 0 power. So in this case, what's being raised to the 0 power is the positive version, 12, okay? And then we've got the negative out in front. So notice the difference between what's in green and what's in navy blue there, okay? Negative 12 in parentheses to the 0 power is positive 1. Negative 12 to the 0, no parentheses, is equal to negative 1, okay? It's really important that you clarify that and understand that right now so you don't make mistakes down the line, okay? So those are numbers to the 0 power. If we've got an expression, an algebraic expression involving a variable to the 0 power, that's also 1. It doesn't change because we're dealing with a variable. So x to the 0 is also equal to 1, as long as x is not equal to 0, okay? Negative exponents. A non-zero number raised to a negative exponent is equal to 1 divided by that same number or expression raised to the opposite exponent, okay, which would in this case be positive, all right? Again, we can't have a 0 here to a negative power because that means we've got 1 divided by 0, which also is not defined, okay? But as we go through these examples, I'm gonna use some terminology that I've always used, and I think it'll be helpful, okay? So if we've got 5 to the negative 2, we've got that expression's in the numerator, okay? What I call it is moving it through the fraction. I'm gonna move that 5 down to the denominator, okay? And it changes the sign of that exponent, okay? And again, in class, you're gonna hear me call that moving it through the fraction, from the numerator to the denominator, or vice versa. It works going either way, okay? So now I can evaluate that. 5 squared we know is 25, so when I evaluate 5 to the negative 2, I get 1 over 25, okay? Next one, 2 to the negative 5. Again, I want to move that 2, that's the base, with a negative exponent. I want to move it through the fraction down to the denominator. That changes the exponent to positive, and now I can evaluate that, okay? 2 to the 5th power means 2 times itself 5 times, which is 32. So I get 1 over 32. So 2 to the negative 5 is 1 divided by 32. Next one, x to the negative 4, whether you're dealing with numeric expressions or numeric bases or variable bases or algebraic bases, nothing changes. We're going to move that through the fraction to the denominator, and we get 1 over x to the 4th, okay? All right. We also got to remember we're talking about non-zero numbers. In this case, x can't be 0, or we would have an undefined expression. All right, so let's move down to the example problems. Let's give these a try. If you want to, you can pause the video here. Okay, let me scroll down. You can pause the video and give these a try, and then come back to us. All right. So we've got a negative 2. Notice the parentheses. Look at 1 and look at 2, okay? There's a difference here. If you want to look back up at the examples and how we handled those with parentheses and without parentheses, give those a look before you give these a try, all right? So we've got parentheses. I'm going to move it through the fraction. So that's 1 over negative 2 to the 4th power, okay? And negative 2 to the 4th power is negative 2 times negative 2 times negative 2 times negative 2. So we're multiplying that 4 times. So that's a positive value, and 2 to the 4th power is 16. Okay, so 1 over 16 is my answer. All right. In the second one, okay, remember, we're only moving that base 2 through the fraction. So my numerator here is 1. This should not be written this way. This should be a negative 1. Okay. So that negative should be up here, not in the denominator. Sorry about that. So my numerator is -1 divided by 16, okay? So this is the correct answer. There should be a negative here, and this negative should be gone. Sorry about that. All right, number 3, we're going to move that 10 through the fraction down to the denominator. It's 1 over 10 cubed, okay? 10 to the third power is 1,000. So my answer for number 3 is 1,000. All right, and number 4, anything to the 0 power, again, we know to be 1. All right. All right, so in the next few examples, I'm going to keep this video going. We're just going to do one video here and not break these up. Okay, we're evaluating expressions. So I'm going to use variable expressions, but given a value for that variable. All right, so we've got a to the -3. We want to evaluate that when a equals 4. All right, so I'm going to substitute, use the substitution property. I'm going to replace a with 4. So now this is just like the examples we did in 1 through 4. I'm going to move that through the fraction down to the denominator. It changes the exponent from negative to positive. And now I just want to simplify 4 to the third power, which is 64. So I get 1 divided by 64. All right. Number 6, let's give this one a try. X to the 0 times y to the -2. And we want to evaluate that when x is 8 and y is 4. All right. So I'm going to replace x with 8, and I'm going to replace y with 4. All right, so I've got two things going on. I've got a 0 power here, and I've got a negative power here. So let's evaluate those. My numerator becomes 1, because anything to the 0 power other than 0 is 1. And I'm going to move this expression, just as 4 to the -2 here. I'm going to move it through the fraction down to the denominator so I can change the sign of the exponent. So that gives me 1 over 4 squared. And I should know 4 squared is 16. So my answer for number 6 is 16. All right. Last thing, simplifying expressions that have these exponents, either 0 exponents or negative exponents. All right. So first off, when I look at number 7, all right, I need to understand this -3 is its own entity. Okay. It's a constant. It's the coefficient of this expression. So I'm going to treat it like that. It's kind of like there's an understood exponent of 1 there. X to the 0 is another entity. Let me just try to highlight that x to the 0. It's not cooperating, but this x to the 0 is its own entity. We're going to treat that individually as well. And then my y to the -4, I'm going to do the same thing. So I've got a constant, I've got an x variable, I've got a y variable, and I'm going to deal with those individually. All right. So -3, again, is understood to be to the first power. So that's going to stay in the numerator. X to the 0 is 1. It's going to stay in the numerator. Y to the -4th, however, I've got to deal with that negative exponent. I move it through the fraction down to the denominator. It changes signs from -4 to +4. Okay? And then I just want to simplify. The only thing I can do is simplify in the numerator. -3 times 1 is -3. My denominator stays unchanged. Y to the 4th. Okay, so this is the answer for this expression. All right, pause the video if you want, give 8 and 9 a try, and then we'll come back. All right. Okay, number 8. We've got our expression, okay? Again, remember, number 7 is its own thing. I'm going to deal with the number 7 like it's a constant, because it is, to the first power. So it's going to stay in the denominator. Notice my b expression and my c expression have negative exponents. I'm going to move both of those to the other half of the fraction so those exponents become positive. So when I simplify this, this is going to be my answer. The c moved to the numerator, becomes c to the +2. The 7 stayed put because it was to an exponent of 1. It's a constant. It's by itself. It's its own entity. And this b here had a -3 numerator in the numerator. It had a -3 exponent, in the numerator. I needed to move it down to the denominator to make that exponent positive. So this is my answer for number 8. All I had to do was move the b expression and the c expression to the other half of the fraction. All right? Pause again, give number 9 a try. We've got a 0 exponent, we've got 2 negative exponents, and we've got a positive exponent. How do you think we're going to simplify that? All right? Okay. 2 to the 0 is 1. This r expression has to go to the denominator. This s expression has to go to the numerator. But this t expression already has a positive exponent, so it's going to stay put, okay? So what's going to happen is this. My numerator becomes 1 times s to the 5th. 2 to the 0 is 1. S to the negative 5 moves to the numerator, and we get s to the 5th, okay? My denominator, remember this r expression moved down to make that exponent positive. T already had a positive exponent, so it stays put, okay? All these bases are different, so I can't combine anything here. We're going to learn that in the very near future. So my answer, I'm just going to get rid of this 1 because 1 times s to the 5th is s to the 5th. My denominator doesn't change, and that's my answer for number 9, okay? So that's how we deal with exponents that are either 0 or negative.